So when light strikes a surface, what happens? When light strikes a surface, what happens? When light strikes a surface, undergoes following phenomenon. What are those phenomena? These phenomena are reflection, number 2, absorption, number 3, transmission. So you remember, when light strikes a surface, it undergoes 3 phenomena. One is reflection, the another one is absorption, the another one is transmission. So let us see, here is a surface. And surface, striking surface. So there are different types of striking surfaces. Then what is reflection, absorption and transmission? Let us see. This is a normal. A ray hits or strikes a surface. This particular point is called point of incidence. Then this is the incident ray. This is the reflected ray. A part of it is absorbed by the medium, so this is called absorption. This is called transmission. So now, this is reflection, this is absorption, this is reflection, and this is transmission. So how can you feel it in your day-to-day life? That is the important question. How can you know that the incident ray is some part of it is being reflected, some part of it is being absorbed, and some part of it being transmitted? How can you know? देखो तमे गोटे टब रे गोटे बेसिन रे किसी पानी नियो, you just look at your face, then you just go and stand in front of a plain mirror and you look at your face. In both the cases, in water, in a plain mirror, what you will find, the image form is here faint. But in front of a plain mirror, you can see your image, which is very sharp. Why your image is faint in water, while your image is sharp in plain mirror. The basic difference is, in case of water, some of the rays, incoming rays, being absorbed by the water and some part of it transmitted through the water. While in case of a plain mirror, actually the plain mirror is what? The plain mirror is a thin glass plate behind which silver coated. Opaque. No transmission is possible. But a little bit absorption is there. How can you define? In case of a plain mirror, there is no transmission, but there is sort of an absorption of light. You see. You just take a mirror, project it to a light. After 30 minutes, you will find the glass plate, the thin glass plate, the front part of the mirror appears to be warm up. You will feel very warm feeling. गरम नहीं बात तुम हाथ लगे को तुम्हें मिरर सामने रे काचे ऊपर हाथ रखिबो देखिबो तम हाथ को गरम लगे ए गरम काहे लागला why he burn because absorption of energy some part of instant ray being absorbed by the thin film of the glass. That's why heat generated. Heat also is a form of energy. So energy, consumption of energy. So some part of the energy is being reflected in the form of rain, and some part is very less amount. Most of the part is being reflected, very less amount being absorbed. That's why heat generated. So this is all about that. What is reflection? What is absorption? What is transmission? And these things happen when a ray strikes on a surface. Here you see there is two medium. This upper surface is the fast medium. This is the fast medium. And the lower surface is the second medium. But if the second medium is opaque, then most of the part of the incident rays reflected back to the same medium. Reflected same medium to reflected most of the part, अधिक also. Very less amount, a small part of it being absorbed. So now the question came, second medium, fast medium. Fast medium is what? This is a thin glass plate. Second medium is opaque. That means from here you can know, you feel there is some differences in medium. So medium also divided into three parts. Divided into three parts. Transparent, number 2, divided into three parts. One is transparent, another is translucent, and the third one is opaque. So, what is the meaning of transparent? Transparent means the medium through which light can easily passes away, easily propagates. Then what is translucent? Part of light passes or propagates through the medium is known as translucent. Then what is opaque? No light propagates or passes through the medium. No light passes through the medium. That is called opaque. So when we used to make a mirror, if this is the reflecting surface, then the backside of it is opaque. A silver coating as a result, almost all lights reflected back to the same medium. So you came to know what are the classifications of a medium. Now you see, from the very first, at the beginning, I draw this figure, sun. So what is sun? Sun is the biggest source of energy, is the biggest source of light. So now here we came to know another word that is called source. So source has certain classifications. Source. Source is two types. One is luminous, another one is non-luminous. The source which emits light is called luminous. The example is sun. The example is electric bulb, which emits itself. Light comes out of it. So that's why it is luminous. But take an example of moon. Moon doesn't emit light. It takes the light from the sun and reflects. And that reflection appears to be moon at night. What do you see? So non-luminous example is moon. Silver surfaces, water surfaces. There are many surfaces which reflect light. That is called non-luminous. So luminous, which has the capacity called luminous. Sun, candle, ball are the example of luminous source. So now you came to know source, you came to know medium, you came to know reflection, absorption, transmission. Let's move to another question. In ray optics, what are the characteristics? What are the characters we have to study? In ray optics, we will study 4 characters. 1. Reflection. Number 2. Refraction. Number 3. Dispersion. Number 4. Diffraction. Try to understand. Reflection. this surface is smooth. So in case of smooth surface, reflection takes place in definite angle. Reflection takes place in definite angle. The angle with the normal. Here you see, here is the normal, here is the incident ray, here is the same incident ray. One incident ray strike the surface, hit the surface and reflected back with certain angle, definite angle. But in this case, there is a ray, strike the surface, hit the surface, fall on the surface and reflected in different angles. Reflection takes place in different angles. Reflection takes place you see, very important thing you just see, one incident ray. But there are 4 reflected rays. But remember, all the 4 reflected rays never generates at a time. That means the incident ray hit the surface, strike the surface in this way and it can reflect back to the same medium either in this way or in this way or in this way or in this way. But in this case, the incident ray strikes the surface and reflected back to the same medium in a certain way. These two paths are the traced path of incident ray and reflected ray. Here it makes a definite angle with normal. But in this case, you cannot define whether the reflected ray moves through this track or this track or this track or this track. So definitely, indefinite, that means no definite angle of reflection. The angle may this, the angle may this, the angle of reflection may this, the angle of reflection may this. So you cannot predict in which angle the light reflected back to the same medium. So that's why this particular reflection is called diffuse reflection. Diffuse. If its name is diffuse reflection, remember, when light hits or strikes a rock surface, then the reflection is said to be diffuse reflection. And there is no definite angle of reflection. But when light strikes to a smooth surface, then there is definite angle of reflection and the reflection is said to be specular reflection. Remember, there is two types of reflection. One is specular reflection, another one is diffuse reflection. Specular reflection takes place in smooth surface, while diffuse reflection takes place in rock surface. Then next move to refraction. What is refraction? When light passes through a transparent medium, either water or oil or any denser substance, it undergoes deviation of path. This is the point of incidence. Point of incidence. Then actually the incoming ray, the incident ray fall on the surface here, strike the surface here. The incident ray strike the surface here. It would have moved in this direction, but won't. It will move in this way. So you see, there is a deviation of path. The ray, incident ray, would have or could have moved in this direction. But it bends to the normal. So the deviation of path, this is called the deviation of path. So that's why, what is the definition of refraction? Definition of refraction is when light strike or heat a transparent medium, it undergoes deviation of path, and the phenomena is said to be refraction. Here you see, this is, let's say, glass. This is air. Or vacuum. This is again air. So you see, this is called interface. Between two medium, there is a phase which connect both the mediums is called interface. Here is another interface. Then what will happen? The deviation will take place in both the interfaces. This is the first interface, this is the second interface. You may say this is the first interface. Try to remember the word. The words are mostly essential to write anything about optics. Interface. So this is the first interface. And this is the second interface. So what happened? The incident ray transmitted through the transparent medium and bends towards the normal and hits the second surface here. Now, at this particular point of incidence, the ray propagates from glass medium to air medium. But here, at the point of incident, the ray propagates from air medium to glass medium. But here, at the point of incidence, the ray propagates from glass medium to air medium. So now, you just draw a normal here. The light supposed to propagate in this direction. The light supposed to propagate in this direction, but no. It will again deviate its path. Again deviates its path, and the direction in which it emerges from the second interface coincide with the incidence ray. That's why you make a parallel line with this. So you see, the light move like this. I'm just making it dark. So you see now, these 1, 2, 3, these are the 3 paths through which a light propagates, entered into a medium, and then emerges out of it. So here you see, there is a deviation. The ray is supposed to go in this direction, but it deviates to the normal. And here, it's supposed to go in this direction, but deviates from the normal. Here the deviation is towards the normal. Here the deviation is away from the normal. Here the deviation is towards the normal. Here the deviation is away from the normal. You see, the angle of refraction, this is called angle of refraction. This is called angle of refraction. This is called angle of incidence. For this surface, this is angle of incidence. This is angle of refraction. For this surface, interface, that means interface. For this interface, this is angle of incidence. This is angle of refraction. For the second interface, this is angle of incidence. This is angle of refraction. As a whole, this is angle of incident and this is angle of emergent. But when we think about the interface, then no doubt the left side is incident angle, the right side is refracted angle. The left side is incident angle, the right side is refracted angle. Refracted angle, not angle of reflection. Refracted angle. Or you may say angle of refraction. So when we studied about reflection, you just remember, here is a normal. The incident ray hits the surface here. This is the point of incidence. is the angle of refraction. This is the angle of reflection. This is the angle of refraction. This is the angle of reflection. Reflection. And this is angle of incidence. So you can write this is I, this is R. The same thing you can write this is I, this is also R. This is I, this is also R. But here the R is angle of reflection and here the R is angle of refraction. So remember, this is the phenomena of reflection. This is another phenomena that is called refraction. You see, you just imagine there is a prism. So in a prism, there are four faces. All the four faces are triangular in shape. This is a prism. You know, the base is a triangle. The base is a triangle. The base is a triangle. This base is a triangle. This base is another triangle. And opposite to this, there is another triangle. So 1, 2, 3, 4. There are four faces. Let's take, this is the front face. This is the front face of a prism. So draw a normal here. Now, point light. Incident here. Here is an interface. Here is another interface. So I may write, this is first interface. This is another interface. So what happened? This is air. This is glass. This is air. So what happened? This incident ray undergoes deviation of path. So it is supposed to go in this direction, but it don't go. This is the rarer medium. This is a denser medium. Denser, gone, condensed. This is a denser medium because it is glass. This is air. This is a free medium, rarer medium. So this is a rarer medium and this is a denser medium. So that's why the light bends towards the normal. and hits the second surface. When light propagates from rare medium to denser medium, the reflected ray bends towards the normal. The refracted ray, this is the reflected ray, bends towards the normal. This is the normal. This is the normal. But what happened? A single ray is here. It splits into several rays. So you draw. Here is one strike point. Here is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 strike points in the second interface. This is the first interface. This is the first interface. This is the second interface. Here is one strike point. Here is 7 strike points. So draw normals. 1, 2, 3, 4, 5, 6, 7. So I draw 7 normals at 7 striking points. So 7 normals are drawn at 7 striking points. Now what happened? At second interface, the ray propagates from glass to air. That means from denser medium to rare medium. That's why all these rays move away from the normal. Let's take a screen here. एक दो तीन चार पाँच छः सात. So I can write this B I B Z Y O R. These are the 7 colors. 1, 2, 3, 4, 5, 6, 7. 7 spots are to be found. 7 spots of different colors. These colors starting from the down to the up: violet, indigo, blue, green, yellow, orange, red. In this phenomena, what happened? The light splits. In this phenomenon, the light splits during propagation through a prism into constituent colors. Constituent colors. So light splits into constituent colors during propagation through a prism is called dispersion. So dispersion is over. Then the fourth point is diffraction. In this case, what happened? You know, in general, light travels in straight line. Okay, light travels in straight line. But what happened? You see, when light strikes to a sharp surface, it bends to the shadow region. That means actually this person this person is a lighted person, and this person, this part is the shadow part, and this part is a lighted part, because light travels in straight line. So no doubt you can find bright light here, and just below this person there must be shadow. No doubt there must be shadow. But no, during the strike of light on a sharp surface, the light, the rays tends to bend to the shadow region. This bending of light on a sharp surface is called diffraction. You can see it. घरे लाइट जोड़ुची तमे डोर टाको खुली दियो तमे देखिबो डोर सीधारे नो डाउट the surface looks bright, but also the adjacent side of the bright area appears to be semi-bright, and this happened only because of the phenomena diffraction. Okay, all the best. Meet you in next class.